Hello students. In this video we are going to be looking at objective number 8 in physical world concepts. This is the second retake version. This was a mandatory retake for the majority of the physics students. And it was mandatory because, number one, most students did very poorly on this objective because it's hard. It's the hardest objective that we've studied in physics. And number two, because it's so important. This is such an important objective to be able to solve literal equations, which just means rewrite literal equations to solve for a specific variable, one of the letters. This is so important in physics and eventually in chemistry and all of your science classes. This is a very important skill, but it's just solving equations. So if you know how to solve equations with numbers and just one letter, I promise you, you know how to solve equations with just letters. Okay, it's the same exact skill, it's just a little bit more abstract. Okay, so let's look at problem 8.1 together. 8.1, we are asked to solve this equation right here. Q equals mct. Now, this equation is taken right from physics. It represents the heat flow from an object with a mass of m and a specific heat capacity of c and a change in temperature of t. Okay, but that doesn't matter at all. Let's just solve it. Okay, we have a bunch of letters. All right, so we have a bunch of letters and we are asked to solve the equation for c. Okay, so I'm going to write down my equation. I'm going to circle c. That's what we want to solve for. Remember, solving a literal equation, so solving an equation with letters, just means move everything to the other side of the equation, away from the thing you want to solve for. Okay? So right now, m is multiplying and t is multiplying the c. Okay? So, in order to move the m and the t to the other side of the equation, all I have to do is do the opposite of what the m and t are doing right now. So I'm going to just do this in one fell swoop. Bam. I'm going to divide the right side of the equation by mt. So here the m and the t are multiplying each other in the bottom. On top they're multiplying each other on top. And that cancels out and that cancels out. And that leaves me with just the c on the right hand side of the equation. But I also have to divide I have to divide the other side by mt as well. mt. Okay? So, what's left over on the right-hand side of the equation, like I said, was just c. So we have solved that equation for c, and what's left over on the left side is q divided by mt. Okay? That's it. That was so not too terrible, right? That's all I'm looking for. C is equal to q divided by mt. Q divided by mt. Now, the second part of this problem asks us to evaluate that equation for these values. Now, we're going to completely forget about what we just started with. Okay? We're going to use that equation and those numbers. All right? Many of you plug these values into that equation and then solve that equation for c. But that's what we just did here. The whole point of solving a literal equation, of rewriting it so that we've isolated one variable, is so that we can plug these numbers directly into that equation. Okay? We don't need to resolve that equation for those numbers plugged in. Okay? That's just extra work. So let's use that equation right there. Okay? If c is equal to q divided by mt, then with these specific numbers, c is equal to 18 on top, and then divided by m is 4, t is 9, so 4 times 9. Okay? So 18 divided by 4 times 9 is 36. So c is equal to, what's 18 divided by 36? Hopefully you can do that in your head, but if you can't, 18 divided by 36, 1/2. or if you want to, I'm going to hit Control and then the Enter button, and that's going to give me an approximation. That did not give me an approximation. Let's try that again. Now it gave me an approximation. Okay, 0.5. C is equal to 0.5. C is equal to 0.5. Easy. Or at least not too bad. Probably not as bad as you feared, right? Now, let's look at the last, not the last question. I wish. You wish. Problem 8.2. Now, we're going to solve this equation. V equals A times T plus V naught. Okay, that little 0 is called a naught. So V, you probably cannot see that, can you? V equals A times T plus V naught. We're going to solve it for T. So, let's circle what we're solving for, T. Down here we're solving for T. Okay, so I just circled what we're being asked to solve for. So I need to get the A to the other side of the equation, and I need to get the V naught to the other side of the equation. Which one do I do first? Well, you need to start outside and work your way in. Okay, the V naught is toward the outside. So the V naught is what we're going to move over to the other side of the equation first. Right now we are adding V naught, so we need to subtract it in order to move it to the other side, because that cancels out. And so we are left with V minus V naught equals A times T. Okay? That little naught, that little 0, is stuck permanently to that V. Okay? These both have V's in it, yes, but they're two completely different symbols. All right? And you can't combine them no matter how hard you try. All right? Now, last step. We want to solve for T, so we need to move the A to the other side. A is multiplying the T right now, so we divide both sides by A. Now, we have to be very careful over here. We need to divide everything on the left-hand side of the equation by A. Everything divided by A. So A's cancel out, and we are left with V minus V naught, all divided by A, equals T. And that's it. That's all I was looking for. So, come back up here. T equals V minus V naught. And by the way, I shouldn't have to tell you this by now, but you are copying down everything that I'm doing, and if you feel prepared, just pause the video and work ahead of me, okay? And then check your answer by pressing play again and watching what I do. So, second part of this problem is to take the equation that we just found and evaluate it for those numbers, okay? So if T is equal to V minus V naught, all divided by A, by the way, this equation has to do with speed equals the acceleration times time plus the initial speed. In case you are curious, all of these equations have real-world meanings, but the real-world meanings, again, do not matter, at this point in time at least. So, we are going to plug in 70 for V, 70, minus V naught is 22, 70 minus 22, and then all of that divided by A is 12, so we're going to divide by 12. So, 70 minus 22 is, 70 minus 22 is 48, so T is equal to 48 divided by 12. 48 divided by 12 is 4. Okay? That's it. Circle that bad boy. So, when the other variables have those values, T has a value of 4. Okay? Let us move on. Oh! Doesn't that formula look familiar? Don't you just love that formula by now? P equals F divided by A. That has a real-world meaning, doesn't it? Something like pressure and force and area. And we're being asked to solve for A, really? Who does that? Who asks us to do such a challenging thing like solving for the variable in the bottom of the fraction? Ugh. Man, someone is mean. So, This we did in class numerous times. This is a very important skill, being able to solve for a variable in the bottom of a fraction. I'm making you do this time and time again because it's so important and because it's hard. It is hard. So let's write it down and let's see why it's hard to solve for a. P equals f divided by a. And we are being asked to solve for a. Here's why it's hard. What do you do? Right? How do you move the f to the other side? And then how do you get the equation to look like this? A equals. Right? It's hard. Well, we have to use a trick. The trick is, well, it's not really a trick. It's not like we're doing anything mathematically, gray area-ish style. Just the way to deal with equations like this when you want to solve for the variable in the bottom of the fraction is you do something kind of counterintuitive. You multiply both sides of the equation by that. Okay? Multiply both sides by a. Don't multiply it by f. That's useless. Multiply it by a. Okay? Because now this is counterintuitive because you're told normally to never move the thing you're solving for. Okay? Move everything else. In this case, we are moving the a to the other side of the equation, even though we're being asked to solve for the a, right? It's just something you have to do. Okay? It's something you have to get over it. Now what this does for us is we have a times p equals, if we divide by a and multiply by a on the same side of the equation, they cancel out, and we're just left with the f. Okay? Area times pressure equals force. AP equals F. Then now, it should be pretty clear how to go from this step to that step. Just divide both sides by P. Okay? P is multiplying the A, so divide it. P's cancel out, leaving us with A equals F divided by P. Okay? So, this required 2 steps. Just like this one required 2 steps, but this one required a counterintuitive step. Okay, so that is our answer for part A. So A is equal to F divided by P. Now, let's evaluate the equation we just found for P equals 2 and F equals 1,800. Whew, that's a big number. So big it's like a year, you know? Okay, so we're going to have, if A is equal to F divided by P, then when F is 1,800 and P is 2, A is equal to the F divided by the P. 1,800 divided by 2 is 900. Bada bang. 900. Now let's try the next problem. I'm kind of running out of paper here, so I'm going to do it over here. Here we're being asked to solve this equation for C. C is right here. Now in this equation you'll notice there's just 2 variables as opposed to 3 or 4 or 4. Okay? And this equation, we're going to see again in class, this equation relates a temperature measured in Fahrenheit to the same temperature measured in degrees Celsius. Okay, so another real-world equation here. So let me write this equation down on our scratch paper. F 8.4 is a problem number. F is equal to 9 divided by 5 times C plus 32. And we are being asked to solve for C. So, this equation actually should remind you very much of this equation up here. Okay? They're actually identical in form. And you're being asked to solve for that thing. Okay? And they're in the same exact position. So we're basically going to be solving these 2 equations in the same way. There's going to be a slight twist with this one, though, as you'll see in a second. So, we want to solve for... I just wrote all over myself. Blue ink. This is... We want to solve for C. So we need to move the 32, and we need to move the 9/5 to the other side of the equation. So the first thing we're going to move is the thing that's farthest away from the C, the 32. Okay, minus 32, minus 32. So we have F minus 32 on the left side, and we have 9/5 times C on the right-hand side. Now, I hope that you recognize that this is a fraction, multiplying the thing you want to solve for. Whenever you have that, in order to move the 9/5 to the other side of the equation, you're going to multiply by the reciprocal, which is 5/9. Okay? Here, the 5 cancels out with the 5, 9 on top cancels with 9 on bottom, and you're just left with C on the right-hand side of the equation. We also need to multiply the left side of the equation by 5/9. But here's a little twist. Not a twist. The twist was that we're multiplying by the reciprocal. But here's another twist. You need to be careful about this. Just like over here, we had to divide everything by A. Same thing over here. We're going to have to multiply everything by 5/9. And the way to indicate that is like that. Wrap the F minus 32 inside of parentheses, and then multiply it by 5/9. Okay? So, an appropriate way to write the final answer would be 5/9 times, in parentheses, F minus 32. Okay? And that's equal to C. Okay? So once we get that, let us evaluate the equation for F equals 77. Alright, so we're going to go down here. We're going to plug in 77 for F, and then we're going to subtract off 32. This is equal to C, and so what's the value of C? Well, let's see here. 5/9. Now, I've gotten a couple questions about, Mr. Wilson, how do you write, or how do you type a fraction into the calculator? Well, remember, this is just 5 divided by 9, right? 5 divided by 9, 5/9, times, in parentheses, 77 minus 32 equals 25. Okay? 25. So, this basically is saying that when the temperature in Fahrenheit is 77 degrees, the temperature in Celsius is 25 degrees. Okay, and I forgot to write the formula over here. When it's solved for C, let me do that for you. Here we go. C is equal to 5/9 times F minus 32 inside of parentheses. Okay, one last one. Oh, not this equation again. Oh, don't you just hate this equation? I'm sure you hate it by now. You've seen it a million times. Maybe not a million times. But this is a really hard equation to solve, okay? And I think maybe only 1 or 2 students were able to do it. But by the end of the year, everyone will be able to solve that equation. I promise you. It's going to be our running challenge, So R is equal to E minus A all divided by A. Now, we want to solve this equation for A, which is right here. And it's right here? Man, who does that? Who puts the letters in different places? Man, I thought cloning was illegal. Look at that. A is in 2 places. That's going to make this extra challenging. Okay? It's going to make it extra challenging. I was thinking, though, the other day that there's actually... I taught you a different way to solve this equation, and I encourage you to watch the first video on this objective if you want to see an equation that looks just like this, basically, with the thing you're trying to solve for in 2 places. I encourage you to watch that video again if you want to see how I originally taught how to solve this equation. But I thought of another way that might actually appeal to you better. We're going to use the distributive property. Okay? Distributive property, but there's no parentheses. Well, yes, there are. The E minus A are in parentheses, aren't they? The E minus A are grouped together. Okay? What I'm going to do is, just like if you, so thought bubble, just like if you had seen something like this, R equals 3 times, E minus A. The distributive property would tell you to take that 3, multiply it by the E, and multiply it by the A, like that. The negative A, actually. We're going to do the same exact thing over here, except instead of distributing a multiplication, we're going to be distributing a division. Alright? I'm not even sure if you're going to like this any more than the other way I taught this. R equals. So, we're going to take the A, we're going to give it to the E. So E divided by A, E divided by A, we can do that, as long as we do this as well, minus A divided by A. Is that okay? Is that too bad? I hope it's not too bad. I hope this will be a little bit easier for you. Now let's see what we're going to do. Now, Mr. Wilsey, look at what we did now. So it was bad enough having 2 A's, but now we have, are you kidding me? We have 3 A's. This looks like we made this problem even worse, right? Well, did we though? Last time I checked, A divided by A, anything divided by itself, is equal to 1. 1. So we get rid of 2 of these A's, we just turn them into a 1, right? Now with everything else we have here, this is actually a negative 1. E divided by A, R equals. Okay, so R equals E divided by A minus 1. Alright? So this is a different way that we could have changed those 2 A's into 1 A. Okay? We had to temporarily make the 2 A's into 3 A's. Now we have 1 A. This equation should be not too bad to solve, I hope. It's still kind of challenging, okay? What we're going to do, we're going to, that minus 1 really stands out. We're going to add 1 to both sides. So R plus 1 equals E divided by A. Okay? Now, ooh, look what we have here. Just like with this equation, when you have the thing you want to solve for in the bottom of the fraction, what do you have to do? What did we do here? We multiplied both sides by the thing we want to solve for to get it out of the fraction. Okay? So we're going to get rid of this fraction by multiplying both sides by the denominator, which is A. A. Okay? Now, just like in, what was it? Just like when we were solving this equation, let me show you the work there. Right here, when we multiplied both sides by 5 over 9, we had to wrap what we already had over here in parentheses to indicate that we're multiplying 5 over 9 by f and the negative 32. Okay? So we're going to do the same exact thing here. This is not correct. This is correct. Okay? This says that the A is multiplying the R plus the R and the 1. Now the next line after this is what we have over here. A times R plus 1 equals E. Not too bad, right? One last step. Do you see what it is? We want to solve for A. So we need to get this whole R plus 1 bit to the other side. The R plus 1 is grouped together. We can move it over to the other side as a group. Plus 1. So the R plus 1 in parentheses cancels out. And we are left with A equals E divided by R plus 1. That was awful, wasn't it? That was so awful. Well, just wanted to show you, that once you think you have solving equations down, Mr. Wilson throws you another equation that is far more challenging, but it pushes you, okay? It pushes you to really understand what you're doing here, and it pushes you to greater fluency in solving equations, you know, having more tricks up your sleeve, okay? That's really what physics is all about, having tricks up your sleeves. You know, physicists are very shallow people. You know, we're all smoke and mirrors, right? This is all smoke and mirrors. Now, are we still not done? This is driving me nuts, man. My audience is probably dropping like flies over here. A equals E divided by R plus 1. That feels so good to actually write something on the paper, doesn't it? Instead of all this. Now, our final task is to evaluate. Evaluate this equation for these values. So we're going to find that A is equal to E is 46, R is 0.15, and then we're adding that 1. Okay? Now, let us compute this. So, we're going to have 46 divided by, in parentheses, 0.15 plus 1. Bada bing. 40. All that work for a measly 40. A is equal to 40. And we're done. So, review over what we've done here. We've done a lot. This is a very challenging objective. 20 points worth. Okay, this is a 20-point objective. It's a very important objective, but it's also very challenging. And I'm probably going to give you this as a mandatory retake again because it's so important and so challenging. So, hope you learned something.